Alright, for homework 9-4, I'm going to have you copy all this work on a separate piece of paper, write down the 5 words, and then for my honors classes, I want you to document it on your slides. My regular Math 1 classes, I'm just going to have you turn this work in. This will make up your 100-point quiz that you should see on cue. So write all this work and the 5 words. Document on your slides, honors class, turn in the regular math classes, and this will make up your 100-point quiz, I promise. So again, write down all of this. I know it's a lot, but it's going to help you study. For this first one here, I want you to see that these are timesing by a fourth. I'm dividing by 4. So we never write dividing by 4. We write that as timesing by the reciprocal of 4, which is timesing by 1/4. And then knowing that timesing by 1/4 to the right, you're doing the opposite, timesing by 4 to the left, and that gives me 48. And that should make sense because 48 divided by 4, or 48 times 1/4 is 12. 12 divided by 4, or 12 times 1/4 is 3. 3 divided by 4, or 3 times 1/4 is 3/4, times another 1/4, 3/16, times another 1/4, 3/64. Notice the 3's are not changing because every time you're multiplying by 1/4. But again, going to the right, timesing by 4 to get that 48. And then those are everything you need to write the 3 equation forms I was looking for today. The first one is, of course, the recursive form. So the recursive form, in its generic form, is f of x minus 1 times r for this problem, because this is geometric. But for your answer, I didn't want that r there. I wanted you to replace that with the actual common ratio number. Plug that 1/4 right there. So my first answer for the recursive pattern for this geometric is f of x equals f of x minus 1 times 1/4, which means every additional term, take the 1 before it, times it by 1/4. That is the recursive pattern. Also, I wanted you to write the explicit forms for this, which are used to jump ahead in the sequence, like the 8th term or the 20th term. So that would be, in its generic form, f of x equals the 0 term, which is 48, times this r number 1/4 to the x power. Don't use this 4 because that's to the left. Use the multiplied number to the right. So if I plug those numbers in, that 48 goes right there for f of 0, and that 1/4 goes right in there for r. So when I want the equation, I'm going to take those generic forms out of there and put the real numbers that match that sequence. So 48 for the f0 term times 1/4 raised to the x power. So if I wanted to find the 10th term, I would plug in 10 right there. Or I could use the first term in the sequence, instead shift over 1 to the right, times that same r to the x minus 1. And again, that 12 would go right there, and that 1/4 right back in there for r. So the final answer I'm looking for, with those numbers that match the sequence plugged in, is the 12. That's the first term. When x is 1, y gets spit out as 12, or f of x, times 1/4 to that x minus 1 power. So again, this is the recursive form for this geometric pattern. That would be a J graph going up like this. And these are the 2 explicit forms I could use to jump ahead. Next problem. These are your x numbers. Whoops, I got that backwards. These are my f of x numbers, and these are my x. So again, you're not trying to find the rate of change of these. You want to focus on the f of x numbers. The first word is come. Come. Alright, so for this one, focusing on those left numbers, the f of x numbers, going up by 3 going up by 3. That is my common difference, my D, because this is arithmetic. You are subtracting by 3 going up, so that 0 term would be 15 minus 3 gives you 12. So again, for the recursive pattern, since this is arithmetic, the generic form is plus D, not times R like this geometric one. And then I don't want that answer. I want that replaced with the actual common difference number, which is 3. So the recursive form for this is f of x equals f of x minus 1 plus 3. Please don't be confused. This is nothing more than to find this sixth term, use the number before it, 27 plus 3, 30. That's what you did right there. That's the recursive form. Use the number before it, add 330. To find the next one, use that 30 plus 3, 33. The explicit forms are used to jump ahead, like maybe to the 7th term or the 8th term. And again, the generic form for these arithmetics is D times X plus the 0 term. So I replace that D with that number that's going up, that 3, my common difference. And that 12 is when x is 0, what y or f of x is. So the final answer with those generic forms popped out of there, and the real answers would be 3 times x, the slope number always in front of x, plus the 0 term 12. I want you to also use the other one, which has you shift down to the first term. So you could use that same D, but x minus 1 if you're going to the right on the x-axis, plus this f1 term. So again, there's my D number. The f1 term is that 15 right there. So if I replace those, plug in that 3 for D, leave that x minus 1 in parentheses, never change that, but instead of adding 12, add 15. And just remember, these are equivalent. If I was to distribute this 3, that would give me 3x minus 3, and then that negative 3 and 15 give me 12. These are the same, just in disguise. They're equivalent. If I wanted to find the 10th term, I'd plug in 10. I did not have you use any of these today. I just wanted you to list the 3 functions that match each of these sets of data. Recursive, both forms of explicit. Recursive, both forms of explicit. All right, the next problems. Again, label and know the numbers going up by 1 are x, and the other numbers are your y numbers or the f of x. So you're focusing on what's going on between these numbers, not the ones up here. I could see that these are timesing by 2, which means if I back a step, go to the 0 term, the opposite, dividing by 2, rewrite that as multiplying by a half. So 5 times 1/2 gives me 5 over 2. 5 over 1 times 1/2, trying to show you the structure of that. Straight across gives me 5 over 2. That is my 0 term. That's my first term. So the recursive for this one right here, again, identify as timesing. That's geometric. Don't do the plus D1. Do the times R1. Don't write it like that. Replace it with the real number that it is if I'm wanting the equation. So this is f of x equals f of x minus 1 times 2. That is my common ratio. And again, this is nothing more than to find the 6th term, use the one before it, 80 times 2, 160. That's all this is. The second word is in. All right, now both forms of explicit. I want you to use either the f of 0 term times r to the x, where I replace that f of 0 term with what it is, 5 halves. I put that 2 in there for r. So when I replace those, don't write that. That's not the equation. That's just the generic form. I don't want that. I want the 5 halves put right there times 1/2 to the x power. I'm sorry, don't use a half. That's my mistake. Use the one going to the right, 2 to the x power. Common mistake. Or use the first term, f of 1, times that same r to the x minus 1 if you're shifting over. So that 5 is going to go in there, and then that 2 is going to go in there for my common ratio. So the second form, using the f1 term, replacing those with their real numbers, f of 1 is 5 times that same common ratio 2, but raised to the x minus 1 power. Those are the explicit forms. So again, remember, if you're going to the 6th term, take the 1 before it. The 5th term, 80 times 2, 160. The 6th term, 80 times 2, 160. That's the recursive pattern. The 7th one, take that 160 times 2, 320. But if you're skipping ahead to, say, the 9th term, then you would show that 9 right here as what you're plugging in. And then when you plug that 9 right here, that's where the actual math would work. Or you could use this one and plug that 9 there and multiply 5 times 2 to the 8th power will give you the same answer. Next problem. This one, again, noticing that these are my x numbers, these are my y or f of x numbers, which means I'm focusing on these. Going down by 3. Going up, adding by 3 for this table. So the 0 term would be 13. Again, the generic form, this is arithmetic. Adding, subtracting, always arithmetic, straight line, always d. So the recursive function plus d, replace that with that negative 3. So that plus and that d go away, and I replace it with minus 3. Or define each successive term, take the one before it, minus 3. This 5th term, take the one before it, 1, minus 3, negative 4. 5th term, negative 4. To skip ahead, again, for these arithmetics, don't use f of 0, f of 1. Use d times x plus the f of 0 term. So I get that d from that negative 3, and I get that f of 0 term right here, 13. So this equation, with those replaced, never write those like that. I want the actual numbers in there. Would be negative 3x plus 13. And again, plugging in any of these x numbers will give you this y number. Plug in 2, negative 6 plus gives you 7. Or d times x minus 1 plus the first term in the sequence. So d would be negative 3 still, but the first term would be 10 right here. So if I replace those, I get negative 3. Don't forget the negative. Got to be negative. Negative 3. And then parentheses x minus 1 plus the f1 term right there, 10. And again, just remember, these are equivalent. These are equivalent. These are easier to see because this gives you negative 3x plus 3 when you times right here. Negative 3 times negative 1. And then that positive 3 and that 10, 13. They're equivalent. So again, recursive, to find that 5th term, use the 1 before it, 1 minus negative 4. Explicit, to find the 10th term, plug in 10 here to show the number you're plugging in. But when you plug in 10 here, that's where you would do the actual math. Okay, last two. If it's just dots, you still need to get these numbers from it. You need to go back to day number 0. So this is day 0 right here. So if this is 3 dots right here, There's 5 dots right here, 7 dots right here. I could see clearly it's going up by 2. Arithmetic straight line, constant rate of change, D. Subtracting 2 gives me how many dots at day 0? So 3 minus gives me 1. So at day 0, 1 dot. Plus 2 is 3, plus 2 is 5. The recursive form for this pattern of dots would be f of x minus 1 plus d, because it's arithmetic, adding. Replace that d with the number that it really is, which gives me f of x equals f of x minus 1 plus 2. So to find day 4, take the 1 before it, 7 plus 2, 9. That's the recursive pattern. To jump ahead, I need you to use dx plus the 0 term. So there's my d. My f of 0 term for this one is my 1. So this equation would be f of x equals, I'm going to erase that, would be that common difference number 2 in front of x, 2x, plus the f of 0 term, which is 1. How many dots at day 2? Plug in 2, 2 to 5. If I want you to use the f1 term, that's d times x minus 1 in parentheses plus the function at the first term. Replace that d with 2. Replace f of 1. Again, sorry about that little glitch. I'm back. But again, replace that d with the 2. And replace that f of 1 with 3. So my final answer for that explicit form, using the f1 term, would be 2 and then x minus 1 plus that 3 right there. And of course, 2x minus 3 minus 2 and 3 give me 1. Those are equivalent. Same answer if you plug in for x. Next dot 1. And the third word is 4. 4. So for this pattern, 2, 6, 18, you need to count. I'm multiplying by 3. Makes it geometric, makes it r, makes it one of these equations up here. Going the other way is dividing by 3, but we don't show dividing by 3. We show that as multiplying by 1/3. But that's the same, because 18 divided by 3 is 6, or 18 times 1/3 is 18 divided by 6. 6 divided by 3 is 2, or 6 times 1/3 ends up being 6 divided by 3, 2. So if I take that 2 times 1/3, it gives me 2 over 3. Again, showing you the dynamics here. Positive 2 times 1/3 straight across gives me 2/3. If I wanted you to find day -1, this times 1 more 1/3 would be 2/9. Next one would be 2/27. Alright, so that's all you need for this one to give me the equations. I got my common ratio. This is geometric. So this is f of x, not plus d. Careful, careful, careful. Nope. This is times r. Common mistake. You're not adding here. So I'm going to replace that. Nope. Be careful. This is times r, not plus d. Again, trying to erase that. I'm sorry. No good. If it's geometric, never add d. If it's geometric, times r. So I'm going to replace that r with 3, which tells me the recursive form for this is f of x equals f of x minus 1 times 3. Or to find day 4, take the term before it, 18 times 3, 54. F of x equals f of 0 times r to the x. Replace that f of 0 term right here. Replace that 3 number right here, which gives me the explicit form used to jump ahead in the sequence as 2/3 times the common ratio 3, raised to the x power. So I'm going to fix that up a little bit. Sorry about that. So 2/3 times 3 raised to the x power. If I want to shift over and use the f of 1 term, you can, because you could also do geometrics by taking the f of 1 term times r to the x minus 1 power going to the right, replacing f of 1 with 2, putting 3 in there for r. So this ends up being f of x equals, with the real numbers in there, 2, which is my first term, or an x is 1, y gets spit out as 2, or f of x is 2, times 3 to the x minus 1 power. If you were to find the fourth one, if you plug in 4 right here, 4 minus 3 gives you 3 to the third power, 27. 27 minus 2 times 2, 54. All right, last two, graph ones, and then the ones on the back. So for these, just find the 0 term, first term, second term, third term. 0 for x, 1 for y. 1 for x, 2 for y. Over 2 for x, up 4 for y. And you can see these are going up by 2. So these are my y numbers, f of x. These are my x numbers. To find that recursive form, just replace that r with what I'm timesing by here, timesing by 2, timesing by 2. So the recursive form for this is f of x equals f of x minus 1 times 2. So if I wanted to find this third one, just take 4 times 2 would give me 8 up here. You can see that curve. Then going backwards, this would be 1/2, 1/4, 1/8. That's how those numbers shrink to the left. To find the explicit, use the 0 term, that 1, plug in that r, gives me the explicit f of x equals that 1 plugged in there for f of 0 times 2 raised to the x power. Or if you're using the first term instead, that 2 right there, again, these are your x terms, these are your f of x. F of x equals the first term, when x is 1, what y is. Again, I should have labeled these as x, these as f of x. Sorry about that. But that 2 goes right here. 2 goes in for the common ratio. So this ends up being positive 2. The first term, when x is 1, y gets spit out as 2. F of 1 is 2. Times the common ratio 2 raised to the x minus 1 power. And again, the way it works, to find this fourth term, take the 1 before it, 4 times 2 gives me 8. I'm sorry, to find this third term here, take the 1 before it, 4 times 2 gives me 8. So this would be over 3 up 8. If I was to plug in 3 to get that 8 using the equations, 3 right here will give me 1 times 2 to the third. 2 times 2 times 2 is 8. That'll give me 1 times 8, 8. Same as over 3 up 8. Or if I plugged in 3 right here, would give me 2 times 2 to the 3 minus 1 power, 2 to the second, gives me 2 times 4, which again gives me 8. So again, to get this third term, take the 1 before it, times it by 2, gives me 8. Over 3 up 8. Or these, when I plug in 3, also give me 8. Alright, this one. This one's arithmetic. 0 for x gives me 1, 2, 3, 4, 5 for y. 0, 5. I should have labeled these as x, labeled these as f of x. Sorry about that. Over 1 up 3. Over 2 up 1. I can see clearly arithmetic going down by 2, going down by 2. Have my 0 term, so I don't have to go backwards. Already have my 0 term. F of 0 is 5. So with that minus 2 going down, that's my common difference. So I replace that d with that minus 2. Again, this is not a times one. Don't make that mistake. It's a add D1. So again, be careful. Know if it's arithmetic D, geometric R. Arithmetic adding, subtracting, geometric timesing. Replace that D with that -2, which shows me that every term over, this third one, take that 1 minus 2 gives you -1 over 3 down 1. That's the recursive form. To find the explicit forms, I want you to use the 0 term. So f of 0. Oh, I'm sorry. No, this is geometric. Nope, it's arithmetic. So d times x plus f of 0. Replace that d with -2. Replace that 0 term with 5. Gives me, for this one, f of x equals -2 x plus the 0 term, 5 plus 5. That's the equation of this line through the points. Y-intercept of 5 over 1 down 2 matches the slope. Or use d times x minus 1 plus the function at the first term. So I replace that d with -2. I put that 3 for the first term right there. So this final answer would be f of x equals -2 and then x minus 1 plus 3. And again, remember that -2 times x minus 1 plus 3 is equivalent to this. -2 times -1 gives me +2, and that 2 and that 3 is where I get the 5. So -2x plus 5, they're equivalent. The fourth word is help. Help. All right, last two. For these, to get full credit, this is how I wanted you to be shown. Some of you got these answers but didn't get credit because you didn't show it the way I want you to. So for these, I want you to see this is arithmetic, so I'm finding the D. If it's geometric, I'm finding how many R's I'm timesing. This is 8 plus this D plus another D plus one more D. So you can tell from 8 to 20 to set up the equation goes from 8 plus 3 of those D's, we write 3D equal to that 20. So if I take away 8 on both sides, that gives me 3D equals 12. Divide both sides by 3, gives me the common difference is 4. So I'm adding 4 each time, adding 4, last one adding 4. So with that common difference number plus 4, 8 plus 4 gives me 12, plus 4 16, plus 4 20, plus one more 4 gives me 24. To get full credit, I wanted to see that. This one is 7, not plus D, but 7 times some number R, times that same number R again. So this would be 7 times, some of you put plus there, nope, 7 times R to the second power equals 28. So right here, the opposite of timesing by 7, divide both sides by 7. That gives me R to the second power equals 4. And then you'll square root. The opposite of squaring, square root. We don't put the number up here. We assume you know that's a 2. Or what two numbers multiply by themselves give you 4, which is 2. That is my common ratio. So I want you to put that up there, timesing by 2, timesing by 2. These other ones, timesing by 2. So 7 times 2, backwards, timesing by 1/2. 7 times 2, 14, times 2, 28, times 2, 56, times 2, 112. 0 term would be 7 halves. Because 7 times 1/2 is 7 halves. The -1, if I kept going to my left, would be 7 halves times 1/2 would be 7 fourths. Going to the -2 would be 7 eighths, and then 7 sixteenths, and then 7 32nds. All right, the last word is anytime, anytime. So do this work, and it will make up your quiz score. Math 1 Honors document on your slides with the 5 words. Math 1, some of my advanced students, you could document on your slides too. The rest of you turn it in on paper. Good luck. See you tomorrow.